Alright, time for another draftphysics.com video presentation. So the Ian Gosling has made another video doubling down on poor logic and really bad physics. So let's go over it again. So I guess we'll make these just lessons. And there's nothing much you can do. They don't want to talk about what they're doing before they do it. They just want to say, look, it produces. So he says, no excuses, KE produces. So this is their evidence. Okay, thoughtless, moronic demonstrations of their ignorance. Yes, that'll prove it. Okay, so we've been over and over some of this stuff, so might as well just make them lessons and just leave it at that. I'll do my part in terms of trying to explain to the belligerently, frankly, stupid. They don't want to understand. So I have a time to, I've tried to explain this time dependence thing, and they just don't get it. So in the universe, we know there's this thing called the speed of light. C. Okay, very, very fast. And so stuff happens at this very, very fast speed. So Earth, and you could do the sun thing, and you could say, the physicists will all agree that if the sun is annihilated instantaneously, without any time taking place in a millisecond, that it would take 8 minutes before the Earth would stop orbiting the non-existent sun. Because the fact is, the force, the element controlling it, has to travel the distance. So whatever it is, the magic, let's just call it magic. The magic has to travel. It's already in the space, and it has to travel just like the light. So the light from the sun would do the same thing. We'd still see the sun for 8 minutes, even though the sun was gone, because the light itself is in this field, and it's moving in the field at this incredibly high speed. Okay, now once you understand that, okay, that the little photons are moving this very fast speed, light speed, well, all of this, the gravity's moving the very fast speed, the light speed, and the magnetism, well, all of them are moving this very, very fast speed. All right, so he's contrived another experiment where he's now just basically converted his experiment into a pulling magnets apart. And he's saying that if he uses a mechanism, swing something in to pull the magnet apart, like make this magnet move away from this magnet, that it doesn't matter how fast he does that. It's the same amount of energy required no matter how fast he pulls the two things apart. Now, I've tried to explain that, no, this is like photons and all this other stuff, that the speed of the force is very, very fast, but the fact is, it happens over a period of time. And so if you were to just move from one spot to another spot, go across this field, and there was something moving the speed of light, photons for example, or magnetism, and it was moving through this area, this gap, and that it would matter, okay, how much you're going to get affected based on how fast you went. So if you go kind of slow, a lot of this stuff moving the speed of light, there's more of it going to hit you. And if you go faster, see this whole, there's little bits of this. I say there's little bits. It doesn't matter. You can just say magic. The magic moves as like a stream of magic. The stream of magic is moving through this field at the speed of light. And there's so much magic. The more time, the more little bits of magic. Okay, so the longer you take, the more total bits of magic will affect you and cause you to be impacted by their magicness. All right, so if you go slow, lots of magicness will hit you. And if you go fast, very little of the magicness will hit you. Okay, so once we got that, then we can move on to the example. Okay, so we're going to pull two magnets apart. Now, physics will tell you, yes, they don't exactly understand the magic of the magnet, but they do understand, again, that it's this field of force, and the more time you take to move the magnets apart, the more work you will have to do, because the force will be acting for a longer period of time, pulling them together. So it'll be, you know, a moment of pull. Well, I won't bother. There'll be a moment of this pulling force, and then there's another moment of pulling force, and another moment of pulling force. And as long as they're close together, that's going to add up. So the slower you pull them apart, just like the slower you lift barbells, let's say, for example, you have a set of barbells, and you're going to lift it. The slower you lift it, the more magical gravity force is going to be pushing you down. The more time in the force, and the force is made out of chunks of force, okay? And the more chunks of force you'll have to interact with. And the quicker you move it, the less chunks of force you'll have to deal with, okay? Just a fact. And the fact still remains with the magnets. So the quicker you can pull them apart, the less total work you'll have to do, because you'll be interacting with the field less. You'll spend less time dealing with this stuff moving the speed of light. So the speed of light stuff basically is time dependent. It comes in clumps of time. 1 second worth would look like this. You know, half second would look like this. A quarter second would look like this, right? It gets less and less the less time you're exposed to it or have to interact with it. So using a magnet, you know, hitting this, you can understand that if you hit it with a higher velocity and move it apart quicker, all right, you will have to deal with less force you're fighting. And the slower you move it apart, the more force you will have to overcome. The more money, you could say, you'll have to pay to get it to where you want it to go. So you can do it the quick, cheap way or the slow, expensive way. Yeah, that's probably enough of a lesson. Now, the fact is you can relate this to distance. You could say that, well, the distance is what's causing the effect, but you can understand that no, because if you do the distance in increments, you can understand that it won't add up, okay? That the velocity is what you really need, and that, you know, if you slow the velocity down to the same velocity each time, you'll end up being more time, and the more time will mean it'll be more work. So it'll look similar. You know, walking up a staircase can look like running up a ramp, but there are different things, and you will use more energy doing this than you'll use going fast and then stopping, slowing down. How else to say it? Well, I think that covers it, frankly. I mean, it's you know, teenager kind of argument. I mean, teenagers should be able to get it. You know, it's not that complicated. It's rain, and you're just saying, how wet will I get? And you get less wet if you spend less time in the rain of the magical forces. The magical forces. All right, we'll pause. All right, so in the video, he has it hinged above the ground. The board will tip much easier now because it's not having to lift any mass to tip, so it would tip in just touching it. Except he's applied a magnet to this lever. So essentially now it's just a lever and a magnet. Okay, so that's all you really have. And the fact is the lever has a fulcrum at the base, and so there is no differentiation in the time. Okay, they're going to be moving the same way. They're not tipping inversely on a lever. They're doing this on a fulcrum. So this will be proportional to this speed. You move the outside fast, you're going to move the inside fast, and vice versa. So you're basically just hitting something into a magnet and trying to pull two magnets apart. And he thinks the theory is that is a proportional way to measure energy. That is, how fast you move it won't affect how much work you do. And clearly I'm arguing that's nonsense. Okay. So what he has observed is that if he takes a one mass and drops it, a distance, that the half mass dropped from less than twice the velocity will produce the same tip. That is, something going 0.4 or 0.5 faster. Okay, it doesn't need to go twice as fast. It only needs to go half as fast, an extra half faster. So he's saying that because he's got one thing going 50 miles an hour and the other thing's going 75 miles an hour, that doesn't make any difference. When, of course, the argument is, of course, it makes a difference. The faster you move the two magnets apart, the less total work you'll have to do. Just a fact of how the force is time dependent. Okay, so anyway, and then the rest of this video he's going to gloat in some way. I assume that's what he's going to do. That this is a brilliant experiment and they should have done it 350 years ago because this proves his Leibnizian fellowship is valid. Him being a Leibnizian is a good thing because Leibniz was right. And Newton, Galileo, and Descartes were idiots and wrong. Okay, that's the argument. I mean, yeah, it is that silly.
So I'll mark these two heights and then we can draw some conclusions.
You're right. You draw conclusions based on false premises. So you have no evidence that magnets are not speed irregular. That is, that they behave, they consume a different amount of energy depending on how fast you bring them together or pull them apart.
Yeah, guys, the one mass required a height of 5 and the half mass height of 11.
And so it's an increase of 40% in the speed, or however you want to look at it. It's 60%, maybe 55% increase in the speed. Something like that.
2 times.
I didn't know he's doing calculator. So whatever. 22. That's really interesting.
2 times.
One half mass is 1.45
times 5 equals 11. So the 11 is 2.2 times the 5. 2.
Yes, it's twice, a little bit more than twice. That's right. And in gravity, okay, that's the argument. Gravity is giving the velocity. That means it's going to be traveling at, say, 40% of the velocity, an increase of 40% in the velocity.
2.2, the square root is the 1.4.
8. Yeah, 1.48. All right, so pretty close to 1.5 again. Yeah, so what? You move magnets apart quicker, you gain an advantage. So again, we're back to the lever arguments and the fact that you have to move the lever, and you really just don't want to pay any attention to these details. That's the truth of it, right? So the fact that it's a time-dependent force is built into the speed of light. Okay, now if you don't understand that all these forces move at the speed of light. They all are in clumps, that are time-dependent. If you're in it twice as long, it's twice as much force. You're in it 3 times as long, it's 3 times as much force. It's a reign of force. That's the way it works, and there's no way getting around that. That the longer you're in a field of force, or the field of force is active, the more work you're going to have to do against that force, because you're going to basically be collecting it. And you refuse to understand it's a time-dependent force. That's your prerogative, but frankly, I'm not going to pay attention to any more videos that are dependent on just a false statement by you that you have any good reason to believe or any good reason to discount the fact that it is a speed of light force and time matters. If you can't understand that, you can't understand that. All right.
So we're going at 1.4 the speed to knock the same bit of wood with the same force.
So it's obviously not the same force because it has everything to do with how fast you pull the two magnets apart. There's less resistance the faster you can move them apart. There's less resistance the faster you move them apart. You will do, in fact, less work. Just like a spaceship taking off from the Earth's gravity, it will do less total work. It will have to use less total fuel, the less nonsense it spends in gravity. The less time it spends fucking around getting to space, the less fuel it will use. Fact. Absolute fact that your entire video is premised on denying. That's the problem with it. It's denying an absolute fact. Okay, and so why should I have to keep debunking videos premised on irrational nonsense? Any force moving the speed of light is a time-dependent force. All right.
Proving that.
So, again, not proving at all. So just deceiving people, and that's all you're doing is creating deception, noise, pseudoscience, rackety crap. You're not defending science and logic and facts. You're defending fraud, fakery, and your petty, whatever, penis envy problems.
Kinetic energy is much closer to the result you would want than momentum, again.
And again, just because of you've lied about how it works. The magnet doesn't apply the same force over different amounts of time. It applies a different amount of force depending on time. And you're ignoring the fact over and over and over and over again.
1.4, here we go again.
Right, here we go again with the fake and the fraud. Okay, so now we'll move to the Dispar guy, okay, who did respond finally to my request that he explain why he's leaving a fake video up. A fraud, a fake, a phony, and I'll draw it one more time just to show just how fake and phony it is. Alright, so he was using gravity to create a velocity, which seems reasonable. Okay, why not? Using a pendulum to create two objects with certain amounts of momentum, or you could say kinetic energy. And the fact is in gravity you have to lift something to give it more potential, okay, in the sense of to give it more time to swing, in the in the gravity. And so the fact is we're going to swing two pendulums, okay, and let's just say these are on the same bottom arc. I won't draw them over each other, but they're on the same bottom arc. If you want to get something like twice the velocity, you have to go just about twice the distance, a little bit more. And, because you're going up 4 times as high by doing that. Because it's a circle, and the more you go up this way on this side of the circle, the more you're fighting the gravity, and the less gravity you're fighting down here at the bottom. All right, and so the simple truth is when you put an object here, okay, and you're going to say, we measure the velocities here, okay, and we find that this one's going 50 and this one's going 100. Well, at this point, this one's not going anywhere near 50 anymore. It's almost lost all of its energy, so it might be going 10. And here at this point, this one hasn't lost much at all. It hasn't started arcing at all. It's, this is a tiny percentage, so it's still going 80. So now instead of comparing 50 and 100, you're comparing 80 and 10, which really isn't a fair fight, is it? No, it's not even close to a fair fight. So it's just a nonsense experiment. It's a lie to say, okay, I measured the velocities here. This is where the real impact, this is where I'm going to measure their energy. And it's clear that one of the objects has lost a lot of its energy before getting here. One of them hasn't lost much at all. Completely unfair contest. So completely, again, fake and fraudy in the sense you're just going to deceive people. And that's all the intent is, clearly. You don't leave a video up that that implies you fairly tested the work they did when you clearly didn't fairly test it. Okay, it's a completely fraud experiment. Now, he claims he got this 1.4 results. Obviously, if he did the experiment correctly, it's not going to be anywhere near this 1.4. So he keeps saying every experiment comes out the same way. And I keep saying, well, that's because they're all shitty experiments, but this one's obviously shit. And obviously, if he did it right, that is, if he moved the carton proportional, so he hit the carton at the same percentage of velocity loss, okay, so that it still was 2 to 1, 2 to 1. If he did it so they hit at the 2 to 1 point, his results are going to be a lot different than 1.4, aren't they? Yeah, they're going to be way different than 1.4. And then he won't be able to say, it always comes out 1.4. He won't be able to say that anymore. But he's not going to redo the experiment correctly. He's not going to correct his mistake. He's not going to, in any way, even annotate the video and say, yes, it's a piece of garbage. It's completely falsely premised. No, none of that bothers him. Because deception is the game he's in. That's what he's doing on purpose. He is trying to deceive people. He's not trying to get to the truth. And he's making that clear. All right. I have to go find the video. All right, so yeah, so Leska, I wrote the comment saying it's a shorter arc, the video is fake science, you should be embarrassed to leave it unannotated, it completely fails to demonstrate what you claim, it is simply a lie. This Leska guy responds by talking about a completely different subject, his own stupid video that I did respond to. It's in the end of one of the other videos. But frankly, I could do a better job of explaining why your argument fails. Okay. And so maybe I'll throw that in here. So this is the extent of Disbar's retort to the accusation that he's a lying sack of scum just trying to deceive people. In the video, I literally said it's a first trial. Well, what does that mean? You literally said in the video, look, it came out 1.4 again. That's what you said in the video. You argued again that look how it comes out my way again. That's what you did. And it's probably a crap experiment. This was a very simple test of a very simple experimental idea. Yeah, and you didn't explain the experimental idea at all. You didn't explain how it was a fair test. You didn't explain any of that. And he says, fine, it's flawed. He doesn't care that it's flawed. Okay, so experiments that you know are flawed should stay up and be sold as if they're legitimate evidence. You know, it's amazing. I'm not going to use it as a test as good evidence. It's up on your channel stated as good evidence. There's nothing to indicate it's not good evidence. It looks like any one of your other videos. How the fuck can you get away with this crap? You know, pretending you're not deceiving anyone. You can ignore this one. Again, it's not about what I'm ignoring. It's about what you're publishing on your channel and saying it's a legitimate experiment. It's not a legitimate experiment. It's a piece of crap. You should acknowledge it's a piece of crap. I mean, amazing. You're making quite a drama out of this. Well, wouldn't you make a drama out of it if the science you cared about did that? Is that what you want the scientists to do, is just publish articles that are wrongly premised and just publish them as if it's a real experiment? They really found entanglement and all this stuff, and it doesn't matter that it's completely illogical what they did. Doesn't matter. It doesn't matter how unfair they were to any of the facts. The setup was completely wrong. Go ahead, publish the article. Who cares? Nobody cares about that being honest or true. I mean, what an amazing concession that, yes, you just basically conceded your intent is to deceive. You don't really care about the truth here at all. You just care about the propaganda, about, you know, trying to prove your point. And it doesn't matter how many corners you cut and how much you cheat. Amazing. All right. And so the other guy does the same thing. So this is an experiment. Obviously, if he redid it, he's going to get a result that's going to be way off of 1.4. So it's not going to be anywhere near proving his theory, and it's going to be really close to proving mine, frankly, because it's that bad an experiment. Okay. So he's going to get a number way off his 1.4 thing. And that'll be the truth. And so you no longer will be able to say, I can't make it go any faster. I can't make it happen any different. Well, you won't be able to say that anymore because that experiment will prove that that's a pile of shit. Okay. And by the way, this experiment will, you know, directly contradicts okay, Gosling's experiment. And it probably has to do with the fact that he used a milk carton that's a little bit more elastic. So the speeds end up being similar just because of the fact that the carton is elastic. It's compensating for the speed differences and basically moving the carton at the same speed. All right. So, yeah, but that's physics. You know, got to understand all these little variables, and they just don't care. They don't care about variables. Just isn't part of their physics conversation. They're not capable of having a physics conversation with the variables included. All right, so the other guy hasn't changed anything either on his propaganda channel. And so it was another experiment, came out their way, all right, but it was wrong, just completely wrong measurement. So he doubled the height, you know, so he was increasing the velocity way beyond twice the velocity. And then he does the experiment as if it was the correct velocity when it was completely the wrong velocity. All right, and obviously if he corrected for that, the number wouldn't be anywhere near his 1.4 anymore, way off. All right, but he didn't choose to redo the experiment. Even though he said he would, he didn't. Okay, and why? Because, yeah, it doesn't work his way. And so it's another experiment depending on friction, okay, and using some notion of friction as a way of detecting how much energy something has. But friction is always tricky, right? Twice the weight is going to be different than twice the velocity. It's a different dynamic about how the energy is stored in the object in terms of how it rolls or how it slides across a surface, and how much interaction there is based on weight and contact. So none of that is very scientific, because there are there's no Hooke's law kind of rule that is a guidepost to friction. All right. So I will, maybe I'll do the Leska argument. We'll see. All right. So I think they're both gravity type arguments, indirectly, one way or the other. One of them, I think, is this simple idea that if I drop something, okay, in gravity at distance, okay, Galileo's 1-3 thing happens. This takes 1 unit of time. This takes 1 unit of time. All right, now obviously the distances are quite different. Okay, now if I did let this drop, the velocity here would be 1/2, okay, of the velocity here. So this is the halfway, half the velocity point. And the fact is, if I drop this, you know, 4 unit of distance thing, if I broke it and I just let it drop 1 unit of distance and then stopped it and then dropped it 1 unit of distance and dropped it 1 unit of distance and dropped it 1 unit of distance, if I did this staircase thing, I will be in the gravity 4 seconds. Okay, and I will lose all the energy every time it stops, of course, so I won't have any reoccurring energy, and it will drop with just the 9.8 because I gave away all the energy when I stopped it. And the inverse happens when you go backwards or lift something 1 step at a time. You're doing this harder amount of work in the sense that you're going to have to do the work 4 times. It's 4 units of time. So you'll do 4 units of time against gravity, where if you just throw it with the proper velocity, twice the velocity, if you throw it with twice the velocity you throw it to go up 1 step, you'll get all the way up to the top, and you'll only be in the gravity 2 units of time, all right, instead of 4 units of time. All right, so that's a pretty simple argument to me. It's pretty easy to understand. You can lift something efficiently, maximizing how much work you do, perfect, and you can do it imperfectly. That is, you could lift it slower and do more work. It's a choice you have. There's a perfect velocity to get to a height in gravity, and if you throw it with that perfect velocity, you can't get more efficient than that. And you can do it a lot less efficiently. No law against that. Too fast, too slow, you'll do more work than is necessary to accomplish the task. There's only one perfect velocity. I have to use this one requires more work to remove this color than the black, which was nice and convenient, but too bad. I have to see if I can find another black of the same make. Anyway, alright, so the other argument is the 10-ton and 5-ton experiment. It's not dry enough. Always something. Alright, we'll try it anyway. Alright, so we're going to take the cart and bang it in, a 1 into a 1, and we're going to end up with a 2, okay, going 1 velocity. Alright, so this has 2 velocity to start with. This has a 0 velocity to start with. Alright, so it's just a plus equals kind of thing. And so his idea is you put a spring here, and the spring will somehow explain how it works. So what he's saying is that you can take the 2 velocity thing, and then it will compress a spring, okay, and then the spring's compression will still be in here when you're done. And no, it won't. This number won't be 1 velocity if you've compressed the spring. It takes work to compress the spring. You have to use momentum to compress the spring. That means that when you're compressing the spring, this one isn't moving. So when the spring is compressing, this one isn't moving. When the spring stops compressing, that's when this one starts moving, okay? So the whole idea is the spring is absorbing the pressure, not the object. The spring is absorbing the pressure, not the object. So it's like a brick wall, and I put a spring on it. The wall doesn't get the energy because the spring is getting the energy. It's consuming it. It's taking away the pressure. The pressure here is low because the spring is absorbing the pressure. The pressure doesn't get to this surface. Say if it was 10 pounds of pressure here, it's only 2 pounds of pressure here because the spring has absorbed the other 8 pounds in compressing. So the fact is if you did this experiment where you push this into the spring, compress the spring, and move the object, the fact is this double object will be less than, okay, 1V, because you used some of the energy to compress the spring and it didn't go into the object and move the object. So you won't be able to use that as an excuse that you still have the kinetic energy here in the spring, because you don't have it in the spring. You do have energy in the spring, but you don't have the same momentum in the object. So you can't use as an excuse for the loss. See, the catch is this experiment has a 100 KE here, and somehow in the result you only have 50 KE. So you've lost half the kinetic energy, and there's no real way to explain where the loss happened. So he's trying to create this gimmick to say that somehow you can do the experiment and conserve the kinetic energy by putting it into some other object. So no, you can't use the fluid twice. So if you've poured the energy into the spring, it means you didn't pour it into the object. That's the simple truth. You can only use the energy once. And if you did make heat, or you did knock a piece off when you combine these objects, well then you'd have to say that you used momentum to do that. You can't say I moved something and I didn't use any momentum. A bowling ball can't hit a bowling pin and keep its momentum. It has to lose it if the pin gets it. So if something moves or heat radiates out of this experiment, it has to be completely proportional to some percentage of the original momentum. The original momentum has to make the heat. The original momentum has to make a piece fly off. An original momentum has to make sound through the atmosphere. You have to use the momentum to make something else that has momentum. If something else is leaving and it has momentum, you have to account for where it came from. It has to come from the original source. So if you did make heat, or you did deform, or you did do all this stuff, you would have to lose momentum. And the fact is, the experiment conserves 99% of the momentum. So if you have all the momentum here, you can't have any compressed springs or deformation or bent or knocked off corners or hot things. You can't have any of that stuff and still have 99% of the original momentum. So again, not a very complex physics argument, and it's absolutely amazing, in my opinion, it's amazing that people are so obnoxious to the facts and the truth. They so don't want to hear it, that they'll deny something so obviously true. Kinetic energy isn't a real thing, okay? It's just a fable, it's just a story, and it just makes a mess out of the simple mechanics of physics, which is motion, mass, moving a velocity. That's all you need. There's no half and there's no squared function. Just mass and velocity. Mass and velocity. Everything, the little electrons are a mass, the protons are a mass, everything moves, and anytime anything moves, it has a portion of energy in the universe, and that portion of energy always goes somewhere. The same energy went in billions of years ago, and the same energy exists now. And you can't change it by putting it into smaller things or putting it into big things. The energy is always the same amount of energy. It all reduces to how many little bits. 1,000 atoms moving 1 mile per hour is the same energy as one atom moving 1,000 miles an hour. The tug of war between those two things will be a tie. Okay, it's the same energy. All right, so that's the lesson for today. Yeah. Basic fact: the force runs the universe in the sense that the force is really just bits, quanta, photons of energy. You know, some visible, some not visible. The little bits hit stuff and convey their momentum to the stuff by being absorbed or being reflected. The force sticks to the big clumps, the electrons and protons. All right, and the electrons and protons are matter. They can hit other pieces of matter and exchange the force, the wetness. So it's just there's an amount of wetness in the universe, and all you can do is you can put wetness on little things, you can put wetness on big things, and it's just how much wetness is there in the universe. Again, an argument made 500 years ago by Descartes, perfectly sensible. It is how the universe works, and it's just tragic that you've taken your silly little totem cult and changed such a fundamentally simple and logical truth and perverted it and distorted it into nonsense for which you don't have any evidence, and that's why you have to do these silly, broomstick, glued to candlestick bullshit experiments. This cheap, cruddy experiments, because you don't have any evidence demonstrating that 1,000 atoms going 1 mile an hour is less energy than one atom going 1,000 miles an hour. You don't have any evidence. All right. Real evidence. Yeah. I just live on a way too stupid planet. Just kind of a waste to have a brain on this planet. Just, jeez. It's just tragic.